Below is a results table showing the distances before a toy car came to a stop after travelling on different surfaces. So we've already done the experiment and we've collected our data and we've put it into a results table, or it's already been done for you. In filling the sheet out, we have, look at the diagram of the investigation. Is the stopping distance measured from the top of the ramp or the bottom of the ramp? Well, let's have a look at the diagram again. And we've got the car up here. There's just a ghost of the car and it's showing the car stopped here. And we've got a label here saying stopping distance of the car in centimetres. So this means the arrow has come to a point, so that's where it's stopped, and there's a 0 here. So that's where we start measuring the stopping distance. So this 0 is at the bottom of the ramp. So to answer the question, the stopping distance is measured from the bottom of the ramp. So we'll say bottom of the ramp. Next question. Is the stopping distance measured from the back of the car or the front of the car? And why do you think it is important that it is always measured from this place? Well, the stopping part here looks like the back of the car. So let's just answer the first part of the question. Back of the car. So why would it always be the back of the car? Well, if we took the distance from the front of the car, that's okay if the car travels along this flat surface. But as you recall from that experiment, the car needed a bit of a push to get over the bubble wrap, and it sort of got stuck at the bottom of the ramp. So if we were measuring from the front of the car, the back of the car would still be past the 0. So, and that would make the experiment unfair or invalid because we're not taking a measurement from the same place, or we're not able to. So I've ended up writing the whole car might not make it to the flat surface, and this would make the test invalid or not a fair test because we can't take an accurate measurement of how far the stopping distance was. The next question is, what is the independent variable? Now remember, the independent variable is what is changed. So what have we changed in this investigation? Well, it's the type of surface. What is the dependent variable? Remembering that the dependent variable is the variable that is measured in the investigation. And what are we measuring? We are measuring the distance that the car travels before it comes to a stop. Next question. What units is the dependent variable measured in? Now we've said the dependent variable is the stopping distance, and the table, we have a table of results, and they tell us that the units are in centimetres. So we write that. Now, this last question, what units is the independent variable in? Now note that the question is not saying it's measured, and we look at our independent variable, well, we can't put units onto this. So we're going to say none. It is also a bit of a clue as to what sort of graph you would put this data in. If you don't have something that is quantitative, that could be measured, and you have categories like cardboard, bubble wrap, foil, that's a big clue that you should use a column graph for your data. So I've provided more information for that last question. I've said none. The variable cannot be measured. It is qualitative, not quantitative. So again, that tells us that we're going to need a column graph to represent that data. I'm going to turn this data into 2 column graphs, one using lined paper because we can do that with column graphs, and then another one using grid paper, but I've changed to pencil because we make a lot of mistakes when we're trying to create the scales for our graph and how we want to look, for how we want it to look. And remember, with any graph, you want it to take up more than half, ideally 2/3 of your page or the grid that you're given. So first we have our independent variable will go on the x-axis. So our independent variable are the categories here, and we have 4 categories. So 4 categories. So just as you would plan out an English essay, you need to plan out your graphs. And the stopping distance range, we're ranging from pretty much near 0 up to 160, and we just might make that around 100, and so our measured range will be from 0 to 200 centimetres. Now with column graphs, the y-axis is going to be the measured variable, the dependent variable, so 0 to 200. So I am going to think that one line will be 10 centimetres, represent 10 centimetres. So I'm going to count from here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So my y-axis will be 20 lines. Put an arrow up there. And each line, this will be 0, 10, 20. So I filled in the scale, the graduations, 0, 10, 20, right up to 200. And I know that I will be able to fit my my stopping distance rate values in there, 8 and 160. It's really important that you label, this is called the y-axis label, stopping distance, and you put the units. So now I'm going to put in my x-axis. So remember, x is you run across, so x-axis you run across, and y-axis is high in the sky. All right, so it points up. Now I have 4 categories, and it's really important with column graphs that the spaces in between my columns and the columns themselves are the same distance. That is really important. So I need my ruler. I have 4 categories. Remember, I have 4 categories. So if I choose to have a gap of 2 centimetres, in the end I decided to not go up to the end. I think that'll be confusing. That might make you think that the gaps between your columns have to be the same width as your columns. They don't. They just need to be the same distant or equidistant between each other. So I've got a gap of 2 centimetres, and I've got a column width of 1 centimetre, column gap of 2 centimetres, column width of 1 centimetre. So now I've put my x-axis labels in, which are the categories: cardboard, bubble wrap, foil, hand towel, and the axis label. It is still types of surface. And now I'm going to plot the data. So for cardboard, the stopping distance was 135. Okay, so here's my cardboard column, and I need to go up to the 130, so 130 and 140. The result was 135, so I need to be exactly halfway between those. Really important to rule with a ruler, not hand draw. You could use your diary, any straight edge. So I've plotted the rest of the data. Now the hand towel was 29, so it's really important I just go below 30 there. You really have to show accuracy and care when plotting data. So I've decided in the title to say it is stopping distance of a toy car over different surfaces. So I've got my dependent variable and independent variable, but the inclusion of the toy car gives context as to what it's about.